Hello, everyone. I'm Chris Colthurst, a solutions architect with AWS, and this is a webinar on the Well-Architected Framework. The Well-Architected program is a framework to measure applications running in the cloud against a set of strategies and best practices. The framework has been compiled by working closely with thousands of customers for over 10 years. The Well-Architected Framework's purpose is to empower people to make informed decisions about their cloud architectures and help them understand the impact of their decisions. The program is a starting point in the architectural process that should be used as a catalyst for further thinking and conversations. The answers to the questions during the process of going through a well-architected framework aren't right or wrong or yes or no. They're based on the business realities and choices that are made for a given system at a given time. So when working on the well-architected engagement, don't just go through the questions. Use your knowledge and expertise to build off the framework and do what's right for you for your given situation. AWS created the well-architected framework to help our customers. It provides a consistent approach to reviewing architectures. It provides best practices and design principles for building cloud-native architectures. And by using the well-architected framework, you will understand risks in your architectures and learn ways to mitigate them. And also, it will help you going forward by hopefully positively influencing future architectural decisions. Now we'll learn about the framework itself. With the goal to educate customers on cloud architecture best practices and ensure they're actively thinking about the foundational areas that are often neglected when designing out systems, the well-architected framework is a set of questions across 5 pillars that are based on cloud-specific design principles. Creating technology solutions is a lot like constructing a physical building. If the foundation isn't solid, it may cause structural problems and undermine the integrity and function of that building. When architecting technology solutions, neglecting the 5 pillars of security, reliability, performance efficiency, cost optimization, and operational excellence can make it challenging to build a system that delivers the functional requirements that meet your expectations. Incorporating the pillars gives a solid foundation to design and operate stable and efficient systems, and for organizations to spend more time focusing on their functional requirements. The well-architected framework has identified a set of principles that facilitates good design at a general or pillar-specific level. For example, this principle is from the security pillar, and it says enabling traceability will allow an organization to log and audit a workload. Cloud computing has opened up the technology space to a whole new world of thinking, where constraints that we used to have in the traditional environment no longer exist. When thinking about design principles, it's interesting to contrast how you would think about this in a traditional environment. In a traditional environment, you had to guess how much infrastructure you needed, and that was often based on high-level business requirements and demand, and often before a line of code was ever written. You could not afford to test at scale. That was just simply economically not a feasible thing to do. So when you went to production, you normally found a whole new class of issues that would arise at a high scale. Any proof of concepts or architectural experimentation was done by hand and was generally done only at the start of a project. You generally had to have a static architecture that was confined, and it was difficult to even think about making a change. You generally couldn't generate data sets that would allow you to make informed decisions. So you probably used models and assumptions to size your architectural versus modeling based off of larger data sets. Finally, in a traditional environment, you would only exercise your run book when something bad had happened. In the cloud, these constraints have been removed, so you can use these principles to take advantage of that. Let's look at an example here. Each pillar has a set of questions with help text to provide context. Also included are best practice answers that we have seen customers be successful with. Keep in mind, it's not right or wrong, yes or no. Maybe your answer for the question will be valid given your context. You still have to apply your own architectural judgment to any given situation or question. We discussed the 5 pillars of well-architected. For the purpose of this webinar, we're going to focus on the operational excellence pillar for the rest of our discussion. If you want to learn more about the other 4 pillars, I invite you to please visit our well-architected page and download white papers dedicated to each of the well-architected pillars. At a high level, operational excellence is how efficiently an organization runs a system. In terms of cloud architecture, operational excellence is the ability to run and monitor systems to deliver business value and continually improve processes and procedures. This requires preparation to define business goals and set up comprehensive monitoring. Having well-defined processes that are automated to manage small changes. Also includes having well-defined and tested processes for responding to events. And then, finally, reevaluating and adapting to changing business and system conditions. So let's look closer at the operational excellence design principles. With on-premise systems, most changes were made by human beings following runbooks that were often out of date. It was easy to become very focused on the technology metrics rather than business outcomes. Because making changes were difficult and risky, they tended to be batched into large releases. Simulated failures or test events were often avoided because resources were busy dealing with real failures or situations. When reacting to real failures, it was hard to take the time to extract the learnings because you were focusing so much on the fixing versus the learning. Keeping up-to-date change management records was manual and hard to keep current, especially with all that firefighting. And then every server was treated like a snowflake, and it was limited the ability to troubleshoot because you potentially had to rebuild over existing architecture versus building out new systems. Again, in the cloud, these constraints of a traditional environment are removed. Changes can be consistently implemented by code, and success can be measured against business metrics. By automating change and making incremental changes, risk can be reduced. Organizations build muscle memory by running game day simulations for failures. They can test recovery processes and learn from these and other operational events to improve and automate their responses. Finally, because infrastructure is now code, one can detect when documentation is out of date and even automate the generation of the documentation. Now we'll look at an example of operational excellence that can be accomplished in the cloud. As we all know, runbooks are created for well-understood events and operational activities. Here we'll look at a security blog written by one of my colleagues, Mustafa. I don't know if you know this, but most of the AWS security blog how-to guides are effectively runbooks. There's a goal and automation in place to satisfy that activity. This blog or runbook is tended to identify incorrect permissions with an S3 bucket and automatically address them. Here's an overview of the steps of an activity that could take place within S3. Keep in mind, in the blog, it's pointed out that this is a reactive approach that should be used in conjunction with prepared and very defined IAM and S3 configurations. Running through the situation, an IAM user or root user in a customer account makes a put object ACL or put object call. S3, upon receiving that call, sends a corresponding API call event to both AWS CloudTrail and CloudWatch events in near real time. The CloudWatch event rule then delivers the event to an AWS Lambda function. So then if the object is in a bucket, which all the objects need to be private, and the object's not private anymore, the Lambda function will automatically make a put object ACL call to S3 to then make the object private. And you can see that in the diagram below. So here's the steps that would be used to set up that automated response. First, you would turn on object level logging in CloudTrail for the buckets that you want monitored. You'd create an IAM execution role to be used by the Lambda function to be called when that S3 object is placed into the bucket. Then you'd create a Lambda function that receives the API call event, checks to see whether or not the monitored bucket configuration is correct, and if need be, ensure that the object within the bucket is private. You'd also want to create the CloudWatch event rule that matches the put object ACL API call event, and it invokes the Lambda function when invoked. Furthermore, to adapt and improve upon this runbook, your team could use Amazon Macie to identify specific information within the S3 object, such as social security number or an encryption key that needs to be kept private, and then use a similar Lambda functionality to lock down that object. Thank you for taking the time with us today to learn more about the Well-Architected Framework and taking a little closer look into the operational excellence pillar. We hope you use this information to make sure that your applications are well architected.